Okay, so this is the last video for Unit 6. It covers the fundamental theorem of algebra, which is a very simple concept. It basically is saying that whatever the degree of your polynomial is, that is how many roots it will have. How many roots, how many solutions, whatever it is, zeros, whatever it is we're calling it. So a third degree or a second degree polynomial, a quadratic, would have 2 roots. A third degree would have 3 roots. A fourth degree would have 4 roots, and so on and so forth. A first degree, a linear, would have 1 root. Anyway, so the degree is equal to the number of roots that you have. This is important because when you're asked to find all of your complex roots, you will know that you've found them all when the number of roots matches your degree. A couple of things to keep in mind. Complex roots always come in pairs, just like irrational roots. So those pairs are called conjugates. Remember, we talked about how a conjugate is the exact same real number with the opposite sign on the imaginary number. The reason why these come in pairs, just like square root answers come in pairs, is because we get imaginary numbers by taking the square root of a negative number. So every time we take the square root, we get the positive and the negative version of it. So it's the same reason that our irrational numbers also come in pairs. So anytime you have an imaginary answer or you have an irrational answer, meaning an answer that includes a square root that can't be simplified further, those are going to count for 2 of your solutions. Additionally, multiplicity needs to be taken into account. Remember, multiplicity is the number of times that a factor appears, which is also the number of times that a solution appears. So if we were to solve this quadratic, we get matching factors of x minus 3 and x minus 3. So we would say that the root 3, or x equals 3, has a multiplicity of 2, which means it's going to bounce. Remember, it's going to bounce off the graph. Anyway, so multiplicity will account for a certain number of roots, which is why sometimes on a quadratic it looks like we only have one x-intercept, and we do, but it bounces off, and that's because that root had a multiplicity of 2. See how it's all connected. Let's take a look at one more example. So this is a 4th degree polynomial, so there should be 4 roots. We can find these roots in this polynomial by factoring. So the GCF is x cubed. When we factor that out, we're left with x plus 1 inside parentheses. We set those factors equal to 0. We get x equals 0 as one of our roots, and x equals negative 1 as one of our roots. So it looks like there are only 2 roots, but actually because that x equals 0 has a multiplicity of 3, that's counting for 3 of our solutions, and then the x equals negative 1 is the 4th one. So we have 3 solutions from 0 and 1 from negative 1, which gives us a total of 4 solutions, which makes sense because we have a 4th degree polynomial. And remember, on the graph at x equals negative 1, where we had a multiplicity of 1, remember, it just shot through like a line. But over here, where we had the multiplicity of 3, it kind of wiggles through the x-intercept as if it were a cubic in that little section. So anyway, just some review information about polynomials in general. Now we're going to be finding every solution complex, which includes real and imaginary, and it's always going to equal whatever the degree of that polynomial is. Okay, thank you so much for watching. This concludes all of our new information on Unit 6 polynomials, and we need to start preparing for our upcoming quiz, our unit quiz. And I'll see you guys in class. Come with any questions that you have. Thank you.